Patil from Rainbow Technologies. I am deeply honored to address you all today on the special occasion of virtual commissioning, the future of manufacturing event. Today marks a special occasion for us as we gather together to explore the virtual commissioning and digital manufacturing portfolio in Siemens. We are excited to share insights, demonstrate, and advancement in virtual commissioning and digital manufacturing. So now the agenda for today's event is like we already done the registration, and after that we will starting with the lamp lighting ceremony by our chief guests. After that, we will start the welcome and first session on welcome and go story of Rainbow Technologies. That will be presented by Mr. Kishore Nimbore, Director of Rainbow Technologies. Then session on NXX, that will present by Avinash Gangaya, Portfolio Development Siemens. Then first case study of this evening, Praxente Solutions, that will present by Mr. Manjunath, Project Delivery Head Praxentech. Then session on virtual commissioning, that will present by Mr. Aman Garg, Solution Consultant Siemens. Then another case study for the innovative engineering, that can be present by Mr. Ashok Sir, Project Manager Innovative. Then we will felicitate our existing customers, felicitation ceremony for the in this session. Then vote of thanks by Mr. Nitin Bakle, Partner Manager Siemens, and in last cocktail and dinners for everyone. So before starting our first session, we would like to take a few moments for a lamp lighting ceremony to make this evening blessed one. We invoke Goddess Saraswati by kindling the lamp of knowledge and wisdom. To perform this ceremony, I would like to invite Mr. Guru Sir, Director Innovative Engineering Private Limited. Please come on the stage. Mr. Vijay Sir, Director Innovative Engineering, please come on the stage. Mr. Narayan Tosu Sir, Director Praxentech Solutions Private Limited, please come on the stage. Mr. J. Kumar Sir, Director Virtual Mantech, please sir come on the stage. Mr. Harsha Sir, Director of Indoor Technologies, sir, please come on the stage.
विनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः
शुभम करोत्वित कल्याणम आरोग्यम धनसंपदा शत्रुबुद्धि विनाशाय दीपज्योति नमस्तुते, which means I bow the down lamp whose light represents supreme knowledge that removes ignorance and help achieve everything. Thank you all. Huge round of applause for lighting the lamp. I will now request all dignitaries to take a seat. Start the event. It's my great pleasure to invite Mr. Kishore Nimbore, the Director of Rainbow Technologies, to share the inspiring growth story of our company. Mr. Kishore Nimbore will take us through the significant milestone, challenges, and achieved that have shaped the Rainbow Technologies into what is today. Please join me giving a warm welcome to Mr. Kishore Nimbore.
Good evening, everyone. So, Rainbow Technologies started in 2018 with an aim of delivering technologies and empowering people and be a part of their journey towards growth. So, we are a team of young, dynamic, and ambitious engineers, always ready to learn more, always strive for the perfection in everything what we do. So, we are value-added partners for Siemens and also for ZW Soft for wide range of products. We are headquartered in Pune, the manufacturing hub of India, and also active presence in South region, Banglor and Hyderabad. So, talking about our mission, empowering people and becoming a part of their journey towards growth by delivering high-end technologies. Our vision to become a leading digital industry software consulting company across the globe. Our core values: integrity, business ethics, transparency, customer delight, respect for individuals. So, talking about our milestones, we have started our journey in 2018 with ZW Soft partner. Then in 2019, we become partner with Siemens PLM. In 2020, we started our Rainbow CAD Center and Consultancy Services. Then in 2021, we become special partner for Process Simulate Technomatics. In 2022, we have developed in-house virtual commissioning expertise. And latest in 2024, we have started India's first Technomatics Process Simulate Training Center in India. So I would like to just add some things. So the woods are lovely, dark and deep, but I have promises to keep and miles to go further before I sleep. And miles to go before I sleep. So talking about awards, so we have received Rookie of the Year award in last year at the APAC meet in Vietnam. This prestigious award is our commitment to excellence and innovation in whatever we are providing. So thanks to all our customers. Talking about our portfolio, so as you know, in Siemens, Solid Edge, NX, then Process Simulate, Plant Simulation, Team Center and Star CCM. So we have, as I told you, we have started training center. So Process Simulate Training Center we are conducting portfolio 2. In portfolio 3 we also have Rainbow Consultancy and Engineering Services where we cater to our customers, mostly their requirement in design and simulation. So these are some of our customers: Innovative Engineering, Praxent Technologies, Indoltech, Virtual Mantech, DVNC Innovative, Amoris, Mega Rubber, Herotech and ProSwarm. So these are some of our waste customers: Spark Robotics, Patil Automation, Rolamath Automation, Dynamic Robotics and Technologies, Sigma Engineering, Suzlon, Iraj Technologies, Varade Pactech, Kotmai Car2 Automation, Trees, Galaxy, Enpro, Citrain, Ushin, Griffin, Porite, Proarc. So you can reach out to us at any time. Thank you.
For that inspiring presentation, we are proud to be part of Rainbow Technologies and excited about the future we will continue together. Thank you. We look forward to the next session. It's an honor to invite our next speaker to the stage, Mr. Avinash Gangaya, Portfolio Development Leader at Siemens for the NX portfolio. Mr. Avinash Gangaya will guide us through the various modules available in NX, providing valuable insights into their capabilities and applications. Please join me welcoming Mr. Avinash Gangaya.
Yeah. First of all, a very good evening to each one of you. My name is Avinash Gangaya, and I'm coming back after a personal trip to Tirupati. So I also like the Saraswati thing that we started. We've also named our second daughter by the name that goes by Saraswati. We named her Medha. So I was able to so much relate to that, and I just wanted to bring that concept up in terms of what we're doing. And I like the way Kishore you started off. Usually we are always in a hurry to look at getting started with it. Okay, we're getting late. We're getting started with it. Let's go ahead with it. But it's always important to seek the blessings of the Almighty, right? So thanks for that, and a warm good evening to each one of you. Thanks for your time. My name is Avinash Gangaya. I'm based out of Banglor, and part of my role, I work with a lot of organizations like yours in adoption of product engineering solutions from our side, from Siemens. I work across the country, across all verticals. So be it in terms of automotive, industrial machinery, heavy equipment, and all that. Hands on, how many of you are familiar with NX as a software? That's a good number. Thank you. So have you also heard about our cloud offering from NX? Okay. We made it very easier for people to quickly understand if it's a cloud offering of ours. We just added another X on top of it. So you can see NXX. The second X basically represents it's a cloud offering. Okay. So with that, let me talk about in terms of what we're doing. Basically, we are looking at in terms of anything that we do from Siemens. We look at it in terms of how does it help any customer address an end-to-end perspective. Not focus it with respect to only a point of pointed solution and all that, right? So we are looking at in terms of how does any customer look at it in terms of okay, how does it help him build and complete a comprehensive digital twin? When I say digital twin, it starts with concept designing. When you're looking at concepting, doing for any of your customers or requirements or your own OEM and all that. And at the same time taking it till the last moment of manufacturing itself, right? How do you do it? Go take it to the level of virtual commissioning and all that, right? But also at the same time, how do we make it more personalized for every user? I've been in the CAD/CAM space for about 1.5 decades now, and I hear a lot of people saying this is easy to use, that is easy to use, and all that. So we have brought in a lot of investments in terms of CAD. We at Siemens, even today, we invest close to $100 million on CAD development alone, and a lot of those developments goes in the areas of artificial intelligence. And I'll show and highlight some of them in terms of what we're doing, so that it makes the life of a day-to-day user as easy as possible, and that's where we'll be focusing on that. And of course, we've been a very flexible and open ecosystem on all that. So, like I said, NX is not meant for only a typical set of type of a user or an organization. It is a very scalable portfolio in terms of it's meant for all types of experience levels. Whether you are starting now or whether you are in the mid-level in terms of the kind of organization you are working on, or in terms of whether you are a very matured organization taking your portfolio to the next step, right? So that is where NX comes into play, and even today we are focusing on, like I said, all the investments that we're doing goes in the areas of goes to the area in terms of how do we make it more productive for the end user, even at the modeling level, right? So we focus on all that, and I did say that we're investing a lot on the product development alone in terms of modeling and all that. And this slide is basically a testimony to that. We've won a lot of awards in the globe in terms of what we're doing on the CAD side, and a lot of them are coming in terms of looking at it in the best feature set, value for price, as well as the way we manage our customers. And of course, this is cut across industries and all. So you all would be wondering what are we talking about with respect to NXX. Let's hear it out. I hope the audio is clear. If not, let me play it out. Can you hear the audio? Okay. Oh, that's okay. I'll probably close this. Audio is not coming. Okay, that should be fine. I'll skip that. So, you all would be heard of NX in terms of what is NX, right? You've heard them in terms of the way we package it, bundle it, Mac 1, Mac 2, Mac 3, so many other modules and all that. So, we've kind of made it easier for customers to look at NXX, which is our cloud offering, and also help in terms of their understanding of how do I get started with. Because everybody looks at, okay, where do I start? What do I start with, right? What's available for me to look at, right? So this is a very simple portfolio that we have added, and anybody would want to start with cloud or NXX. You either choose one of these modules, and if you're familiar with NX before, you would have heard about Mac 1, Mac 2, Mac 3. These are more or less equivalents of Mac 1, Mac 2 and Mac 3. So when you look at Mac 1, we call it as our cloud offering, we call it as standard. In standard, you get all your regular feature-based modeling, synchronous technology for your direct editing, core conversion for your reverse engineering, standard drafting, assemblies, freeform and all that, and of course with sheet metal and ST3D and all that. You go one level up, you get all of this, and some of them in terms of routing, rendering, and PMI, user-defined features and all those things, right? And then the last one, the premium one, is where you will get all the same capabilities and add it up with your advanced assemblies and also in terms of surfacing, freeform capabilities and all that. But one thing that you don't get with your standard on-premise Mac 3 industrial design or product design is the AI features that we talk about. Okay, and what do I mean by AI features? What do I have, right? So let me show you in terms of what we're doing. So the software basically keeps learning in terms of the kind of commands that you use, and then you see if you are starting off now, you don't have to go to the browser cursor at the top. Your cursor is basically more or less can be confined to this. You see there is a small dashboard that keeps popping up here after every command. The software is basically highlighting the next set of commands that you would need, and it keeps learning it all the time. So let's say after you do sketching, what do? You might want to add an extrude. After you do an extrude, what you want to do? You might want to do a chamfer or a fillet or probably do any other activity, maybe another cutout, right? You might want to do any of that. The software is basically keeps on learning it from you. Now the benefit here is two things. Let's say you started off small and then you grow and then your team grows and then you are taking a very higher responsibility and you may not be doing modeling anymore. But you would want to bring it to the same, you are probably bringing in or moving in a different new user to your organization and this role. And that guy can basically get to see the same workflow that you are doing, because the software can create a profile for each one of your users. So if you are logging in, the kind of commands that you would get would be very specific to you as a user, and the kind of commands that would pop up would be very different for a different user, depending on the flow that they are using. So it is very, very personalized for you in terms of the way you would probably go on to build your design. Right? Why is it important? It makes it easier for anyone starting. Right? You don't have to learn, you don't have to struggle to find out what's in different locations of the tools, right? And that's called command prediction, by the way. Second is, this is something that I personally like. We have a lot of assemblies that come very cluttered, right? It has a lot of fasteners, small components, small features and all that. And if I have to quickly pick and choose some of them and to do some activity on top of it, maybe group them, maybe do something on top of it, right? How do I do that? You can see this, we have an AI feature that basically helps you the minute you select a region or a location in which you would want to probably select similar components, right? The minute I select this fastener, you see, I did not have to choose anything here. The software is able to geometrically identify similar looking components and then populate it for me. This is one. Now these are similar or same components, right? Now what if there are similar fasteners which are of different sizes? Maybe length or dia and all those things, right? So that is where again the software basically lets you pick and choose the region that you would want. The minute you pick and choose the region, and then you select just one type of a fastener, and then it also tells you these are similar looking fasteners. When you scroll down, it also highlights here in the selection section that there are other similar, geometrically similar fasteners for you. Now imagine how difficult it would have been for you to select them. Physically going in, zooming out, rotating, trying to identify and all that. If at all you would want to group them and all that, right? So this is where the AI kicks in. Okay, just another example of what we're doing. And this is my favorite. While it's a small feature, but it's very important. You remember we all keep selecting multiple edges, 20, 30, 40 edges, or to fillet them, but only to realize in the end, oh, I forgot one or two of those edges, right? So that is where you select just one edge. The software is able to identify all similar looking edges that can be patterned. And then you select this, and then it automatically applies your secondary feature that you want to do, any activity that you want to do, and then show it to you. You see, I select this, and then it automatically identifies it. It avoids so many clicks that I'll have to do. It will also automatically selects it for me. And of course, you may say that, Avinash, I don't want to select 3 or 5 of them in between. You can always unselect some of them that you need, right? You can also change the sensitivity at the top so that the kind of selection that you're getting can also change accordingly. That makes your life a lot easier as a user, right? So you also see some of these examples in terms of, the minute I select this, it auto selects all of them. But like I said, I can also unselect some of these features to make my life a lot easier. So we are looking at reducing the number of clicks for the end user. And how are we doing it? By kicking in all these AI features to come in and then make your life a lot handy, right? These are some of them in terms of the kind of selections that you do and all that. This is again in terms of similar faces. If I just select the region, maybe the top region and the bottom region, and then say that, okay, in this confinement, I would want you to help me select all the similar looking faces. You see, I just selected the regions and then say, this is the face that I would want. You see, automatically it has searched all of them and then showed me these are all the similar looking faces for you, right? While they are different shapes, sizes and all that, right? So these are the things that helps your life a lot easier. And of course, we all work with the data coming in from different file formats and all that. One on the right is a little familiar for most of us. We are talking about direct editing. Data comes to us in different file formats. But by the way, if you are also not aware, most of the data is usually built on Parasolid file format. Okay, Parasolid is also the same kernel on which NX is also built on, and Parasolid is also the kernel which is owned by Siemens, and close to maximum percentage, 65 to 70% of the world's CAD data are all built on Parasolid. That is also one of the reasons we are able to manage most of the multi-CAD data very seamlessly. You can see the kind of edits that I'm able to do on the software on this imported model very easily, as if I'm doing it on a native file format. Now we don't stop there. We go one level ahead where we're talking about how do I edit the 2D data as well. So if I'm getting any 2D data, you can see I can select the 2D data and then make a similar, the way I'm doing the edits here. I can do the similar edit here without again having access to any of the feature tree, right? Makes my life a lot easier. You can see I can get to have control over the associativity and all those things if you want to create more control points and all that. You can see this. I'm not recreating the data, I'm just modifying the data, making it. Imagine how much time it would have taken for me to recreate something like this, right? So that's where synchronous technology comes in, both on 3D as well as on 2D side, right? One other thing that is also fast catching up, and we're doing a really good job, is model-based definition. When we say model-based definition, people casually call it as 3D annotations. Yes, it is 3D annotations, but it brings in a lot of value when you're talking about the way you build them. And you can see most of the times you just have to select all of those features and then start populating 3D annotation. This is where we also bring in AI. There are a lot of standard logic rules that are available. All you need to do is just select set of features you need, drag and drop, and then boom, it populates all the H7 holes for me here. You see this? I did not have to select all of them. I just drag. I have created a rule already, which you also can create custom specific rules on your own. Again, the minute the dimensions are there, I know everybody asks me how do I put GD&T. We also have a rule for that. You do a drag and drop, it automatically populates your GDNT. And of course, you can always select, unselect, deselect, all those things you can do. But makes your life a lot easier, right? And when it comes to MBD, this is where again we are using a lot of AI in terms of the way you build it. We're not just talking about creating MBD, we're talking about the way you create it, right? Making your life easier in terms of the amount of time that you save. But every time I show this video, I have a lot of customers who ask me, Avinash, this is good, but how do I look at all the CAD data that I've already built? If I would want to recreate them, right? Do I have to go through the same process, right? So that is where I bring up this video always. You see, this CAD model was built on NX, and it also has a 2D drawing associated to it. It does not have any other views or anything, right? You see this proper 2D drawing, everything that's all details are available. So the customer wants to recreate the MBD information by populating all this. How do we do that? The power of AI. Select the entire window and then say convert to PMI. One click of a button, everything gets populated in 3D mode, 3D annotation, including your section view comes into play. You see this, I just selected every single view that I have comes over there for you. Now, a lot of people also ask me what is the benefit of it, right? So including section view and all that. Now MBD is only a start. Where do you use that MBD is where the true value lies. Now you can use the minute this is there, right? We are all creating complicated products now, right? We are not using or recreating the same old products which was there all these years, where products are getting more and more complex. It is very important for you to be able to communicate your product to guys on the shop floor, to guy who's on the procurement team, to your marketing guy, to your customer, to everybody, right? Very important. How do you do that? It's easy for me to look at the design in 3D rather than seeing it on 2D, right? Now once this is built, you can publish this to a 3D PDF and share it for your documentation purposes. Give it to your procurement guy, he can look into it and then say, okay, this is the kind of model I need. Easy for you. You can share it in a 3D PDF to your vendor, supplier. He can look into it, take section view and all those things and then say, okay, this is looking good, this is easy for me to do the tooling and all that. Makes it easier. You can also give it to your guy on the shop floor and then that guy can read this information in his machine, of course, which will auto build the tool path based on the PMI that is there, making your scrap rate low. Basically, we are reducing a lot of those human errors. You can also take this to do your CMM checking to see if there is any deviation, variation analysis and all that. So that is where MBD is just the start. You can take this to the next level. So the true value lies when you are leveraging the MBD there. So that's where we are automating the way you create your MBD to help you see the real value there. So a lot of customers have different use cases. Some of them just want it for 3D PDF, some of them want it for manufacturing, some of them want it for different purposes and all that, right? So makes it a lot easier there. And what we've also done with NX is we've gone immersive. When I say immersive, with NXX standard, you can also see with our value-based licensing and all that, you can actually visualize the entire design that you have using VR. Okay, NXX is VR enabled. It can be any different size. It can be especially for folks who are into services, especially for folks who are supporting an OEM or building their own data. You can see, you can transpose yourself from one location to the other. You can check, you can take design, you can make markups, you can do all of that, right? On VR mode, right? A lot of new products that you're building usually have this, right? Some of them also would want to not just see static data, they would want to see the data move. So somebody said, okay, how do we look at in terms of, if I have a lot of data, but I would also want to see once the data is moving on the CAD side, how does it get updated on this? You see this here. If I come back and of course I can change the realisms in the back end and all that, the kind of scene and all that. You can see if in the real time, if I hide something, move something, the same thing gets populated. So if your customer is seeing this and you are controlling this here, you can basically control what he's seeing, right, during review. Right? So this is not static data, this is real time data. Just taking it one level ahead, if you're looking at doing virtual commissioning and all that, if you're doing virtual commissioning, you build a lot of animations and all that, right? You would want to do that. You can see all the animation that you build will also come up here. But then the minute you want to do a real-time visualization of the animation, whatever you're doing on the CAD side can automatically get populated on the VR mode real-time. Yep. Again, making it easy for you to visualize your design, take right decisions accordingly and all that, right? So just skip this a bit. Okay, play now. You see this, whatever you're doing now, this is happening on the CAD, the same thing is happening on the VR mode. So somebody who has specs like this or a little bulkier one, which is usually used for VR, the same thing gets populated here. So when you're training people, right, when you're communicating your new design to your own customer, to your own team during design reviews and all that, this helps you get a 1:1 feel of the product, maybe from aesthetics, maybe from a lot of other things that you need. VR brings its own value there, right? So that's where this comes into play. And of course, a lot of customers would also want to show their show animation on their product in terms of the way the animation comes in. Let's say if you want to show assembly, disassembly sequences, let's say if you want to show these kind of maybe during events and exhibitions and all of that, right? This is where it comes into play. You can use VR there. All of that you would have, basically what are we doing? We are reusing what you've already built on NX. All you need to do is just publish. Why are we able to do it so much better? This is basically nothing but JD. We can manage assembly, larger assembly, much larger assembly in a very seamless way, right? And you saw a lot of them, right? And there's tons and tons of them, so half an hour is not enough for me, right? There are a lot of capabilities. So capabilities like in terms of sustainability impact analysis, a lot of customers who are exporting to, let's say, Europe, when you have to export to Europe, especially parts and all that, you also have to build, publish or convert to a sustainability report EN 180504 standard. And with NX at the designer level itself, you can run a report that tells you, which is basically in adherence to that standard, and that tells you the amount of carbon dioxide consumed. That tells you the amount of freshwater consumption happening. All the things that you need for generating that report can be done with NX. A lot of people are looking at lightweighting and all that, where you're looking at new age technologies like additive manufacturing. You can do that here. Composites and ergonomics in terms of reach analysis, seating, postures, and all of that. Designer simulations, though. So at the CAD level itself, you can go ahead and then run your design simulation and all that, right? So you can do all of that, and mechatronics for virtual commissioning, mold and die, and a lot of them you saw immersive engineering and all that. So as a customer, all of this will make sense to you. But again, as a customer, it doesn't make sense to buy all of them one at a time, right? Yes? Now, that's where we also have something called as value-based licensing. So you imagine you start with standard, advanced, or premium, one of those bundles I showed. But then for accessing all these add-on licenses, you don't have to necessarily buy a specific module, because let's say today you may buy designer simulation, you may have a need for it for next a month or two, but you end up buying that for next 1 year, while you don't use it for next 1 year, right? Imagine your requirement is done in the first 2 months. What do you do for next 8 months or next 10 months, right? So what if it gives you the flexibility to use any other add-on during the next 10 months, right? That's where the flexibility of value-based licensing comes. Now how it works is, instead of buying a specific add-on module, you buy something called as tokens from us. You start with 100 tokens. Let's say you have about 5 users. All of them start with standard license, right? So at 9 in the morning you start. This guy wants to do human modeling. It consumes a certain set of tokens, and you are left with it consumes, let's say, 26 tokens. You're left with 74. And this guy would want to do something on styling. Again, 74, he consumes certain set of tokens here. Maybe this consumes 35, you're left with 39 tokens. Now this guy is very smart, he's quick, fast like me. So he's finished his work at 10:50. Now the minute he's finished his work, the 26 tokens that were blocked out, right? Basically these 26 tokens are sent back to the pool, so that the pool is replenished now. Okay. Now that the pool is replenished, it is now giving access to all the other users who can consume these tokens. Now somebody wants to do routing, this consumes about 25 tokens, you're left with 40. At 6 p.m. everybody shut their machine down, go back home, have a very good night's sleep, come back home on day 2 in the morning, you are again starting with 100 tokens. So for the rest of the year, you'll always have 100 tokens. And then you can access any of the add-on modules that are available. Now your next question is, what are the add-on modules that are available, right? So this whole list of modules that you're seeing are the list of add-on modules that you can access with the help of 100 tokens. Now the only caveat is you should not cross 100 tokens at any given point in time, and you can access any of these 100 tokens at any given point in time. Let's say suddenly for some project requirements, quickly you might want to have to do routing, and routing consumes, let's say for example 25 tokens. You can quickly launch 4 routing licenses on top of your base bundle that you have, which you eventually did not have in the beginning, right? So what all do you get? You get your standard translators, ProE, step translator, CATIA and all that. You get your extended reality, you get to do a modular design, NX viewer, all the AI features that I spoke about are available here. You get to have our fastener management, sheet metal, advanced sheet metal, weld assistant, advanced assemblies. MBD PMI I showed you is available as part of it or part of this. Draw shape, realize shape, and these two is where again you'll see a lot of value. Appearance and rendering very powerful from our side. Topology optimization, you give your design and then say these are my constraints, I would want you to help me reach my goal. Goal is what? Maybe to reduce the volume or reduce the mass. It automatically runs design of experiments in the backend and runs hundreds and thousands of iterations and gives you good results. And you can also do your design for additive manufacturing, advanced convergent modeling for reverse engineering, piping, tubing, routing and all that. This is where again value for you. Any customer at the designer level, you can do your motion analysis, kinematics, dynamic analysis, and all of that. Design simulation. You can do your animation designer as well to show assembly, disassembly sequences. Publish an AVI file out of it, right? Human modeling, poster prediction, and all that. You can do your formability analysis, mold part planning, and all that. Checkmate to ensure all the checks that are there. A lot of people save their data without having, without applying material to it, right? People just save their data and then publish it. But then when you see that, oh, where's the material, right? So you can have all those things checked here with Checkmate that helps you to run the report. And then these are industry standards. Some of them may not be needed, but you can use your composites on the CAD level itself, right? And aerospace design and all that. This is sticks and fixture. Mechatronics concept designer MCD, which our colleague will also talk about in detail. This is where NX comes into play. Now, so that is the power of NX. So you may ask me how good is rendering. The image that you're seeing at the back end, the yard is basically rendered on NX. And value-based licensing I spoke about, this is basically put from one of our customers. So with that, since I had to rush, I just have couple more. Maybe I'll quickly finish this through. With every seat of NXX, you all always get CAD license, right? You buy CAD, you use CAD, right? But you always generate a lot of data. So where do you save that, right? So now with our cloud offering, with every seat of NXX, every customer, for every license that you're buying, you will get access to an inbuilt data management which is made on the cloud. You buy 5, you get 5 users access on the cloud. Now what all do you get? You get, I'll skip this quickly. You get our MCAD data management, you get our document management, you can do task management, you can do check-in, check-out, you can do revision control, you can do visualization, you can do where used, all of that. As part of NXX, so not paying us anything extra, you get it as part of NXX, ready to be used right from day 1. So it's on the cloud, you can access it right from day 1, any day. And whenever you as an organization feel that you've matured enough to take it to the next level, you can always scale it to our full-fledged team center environment. But this is something that will help you to get started so that you don't have any duplicacy of the data, do not have people overwriting your data, do not have data loss happening. Somebody's going, he's taken a vacation, he's gone to his hometown, and we don't know where the data is saved. Whether it is underscore 1.2 or underscore 1.1, or I don't know. We don't know which one is what, right? So that is where these things come into play, and this data is always on the cloud, making it easier for you, right? Now, every time I present this, I also get a similar question. Of course, this is just a video. I'll skip the video in the interest of time, but this is where you can do, this is NX environment. Within NX, you can launch Team Center. In the browser, it helps you to do all those things that I showed you, right? We can have a detailed discussion. If you're interested, I'll be around, right? I'll skip this. Every time I show the Team Center part, everybody asks me, okay, this is very good. It helps me address it within the organization for me to share data, but how do I bring in my collaborator in terms of vendors, suppliers, all of that? How do I bring that in? That's a big gap, right? So again, with every seat of NXX that you're buying, you also get a capability that will help you address and share your data with your suppliers, customers, subcontractors and vendors. And what is it called? It's called Team Center Share. So what does it do? With Team Center Share, what you can do is you get a URL and an access, create a project. It's a project basically for ad hoc collaboration. You can create it whenever you want, you can delete it whenever you want. But when you create a project, you can also, I'll just let this run a bit. But when you can create a project, you can also bring in any external collaborator, meaning you are from abc.com, your email ID abc@xyz.com. You can bring in any customer or a vendor or anybody with a different domain name because they are external to your organization. So bring them in so that you are able to share all kinds of data, CAD data, documents and all that. Now people may ask me, I can use OneDrive, but OneDrive will not help you to rotate, zoom in, zoom out and see your CAD data, right? It will also not help you to be able to collaborate. So that is where, look at this. So the design head here wants to quickly look at the design and then say make some design changes, right? So he looks into it and then say this is Team Center Share, looks into it and then also makes some comments to it. Adding those comments, say that okay, maybe the fins needs to change, or the weights need to change from 9 to 15 or whatever. Give those markups, annotations and all that and then say this is where I want some change to it. The same information in the same visual format goes back in the Team Center Share. Whatever you create a project, you bring in. And then you also decide the kind of access that they would have. You want them to only just view or you want them to edit. You would want them to view and download, right? So you can do that, right? This is again ad hoc project. You can bring in anybody the way you would like to have, right? Now the benefit here is again, you can add external users like I said, anybody you like. You define a kind of access level that they would have, share it. Now the other person can directly get a mail from us, from the portal and then with the link as well. He clicks on the link, he get to see the annotation, data that you have shared and then once he downloads, after that he can use his software, whatever, if it's the same modeling software, well and good, if not he can use it in different file format, right? But he can always revert back to you on that, right? Now that is one. Now we also have gone one step ahead for the way you would also use the data. I said you can bring it and share the data and all that. Sometimes I would also like to, I've built a fantastic product, maybe a camera, maybe anything, right? I would want to show it. So with the same Team Center Share,
You're a
you
startup
can also see.
company. We're doing dishwashers. Your design engineer is busy designing in our NX CAD.
Okay. So you see this is a dishwasher, right? I've shared the data, I'll upload it on Team Center Share, right? Now I am a CEO or a CXO or any senior level guy and I'm sitting with a customer, right? I would want to show this design to him. I don't have VR, I cannot do that, I don't have a headset. But then you can see, the minute this is shared to me, with the same geometry, the magic will happen when I'm able to open the same data in my iPad. Okay, I get the iPad, I click on this. You see this simple icon, it's called AR. You can place it in real time. So if you have a bike, if you have a dishwasher, if you have anything, you can place it in real time, go inside it, zoom in, zoom out, get a human size feel of it in terms of what we're doing. This again, all part of same NXX that you're buying. Now this is what I just wanted to introduce you to. I'll skip all these things. Some of our customers who've chosen NXX and with that, in the interest of time, I come to the end of my session. So thank you very much. If you have questions, I'll be more than happy to address them. Thank you. Thank you once again.
Thank you, Avinash sir, for the insightful session on NXX. Your detailed overview and expert guidance have greatly enhanced our understanding of NX portfolio and its applications. Now it's time for the first case study session. I am pleased to welcome Mr. Manjunath from Praxen, who will guide us through the adoption of NX at Praxen. Mr. Manjunath will provide valuable insights into how NX has been implemented and utilized within their organization, highlighting key success and lesson. Please join me welcoming Mr. Manjunath to the stage.
It's okay. I can manage. Thank you. Hi all. Good evening. Thank you, Rainbow, to give me an opportunity to present ourselves here. To start with, on the delivery, I think Avinash was saying something like boom. You got a features there. The delivery is not so easy. You know. So
there's a lot of hard work goes in the back end.
We get a lot of booms. Okay, so sorry, it's been in the. It's like so. I just quickly want to dance through like what we are today with 6+ years of maturity in the field. We started and. So the dedicated centers, like it's been like we started locally at Halia because I think thanks to the COVID where we could get the tier 3 where you could get the sustainability when it comes to finding the right people and having multiple domains where we started our deliveries in terms of automotive or industrial, to name it. And also, globally, I think we are connected and delivering the projects. So I just want to just quickly give, this is my team, basically with the IT blend and formally Mr. Nayantasu, myself, Shiv Shankar, we were all colleagues, like we parted from Tech Mahindra post-COVID, and I think Nayan sir, I think he just started even before that. So myself, Shiv Shankar, and a couple of engineers, we started to support here. So these are the team. I'll just not go into. I just want to tell you how the journey started with 2016 with very few people, and then we moved. Today, I think we are with around 300 plus engineers, and this is our facility where we started with Halia. I think we have a couple of places in Bangalore where we are starting. I think totally it's around 100 plus capacity where we are working on the projects. So to name here, I want to say that we are more, working in so many domains, like on the development or validation, the legacy, or tech publication, sustenance, value engineering, reverse engineering. So I think we have grown with a more mature team today, like in terms of, not just to deliver the project. I think we try to connect with the team strategically to make them deliver their project, the pain points to understand in other domains, I mean to say. So tough nut is the BIW, as we always get a lot of beatings, but I think today we have a couple of projects what we have executed recently with NX software, what we have delivered. That's been really phenomenal, like with the tight schedules, so you just have to manage many things there. Not only just the delivery, you get a lot of feedbacks, you get a lot of change in the design, you get the simulation feedbacks, you get the guns. Now that's been like every minute, like boom, boom, boom. So that's been the challenge. But to name here, you can see here on the domains what we work on, like on the electrical equipments or on the automotive or on the industrial. So aero. So recently we started with the aerospace domain, like on the model based, more, that was on the CAD Unigraphics, where we get the model with the model based thing. So where we need to do the conversion. Also a couple of design projects what we started. So that was been very interesting actually, because I think engineers are becoming lazy because of this, what I feel, because you get everything defined in that. So what is the thought process going on when we started way back, when we wanted to do the design? I think it's a paradigm shift today. So, and I think they're finitely defining the with the licenses and doing good business. But only thing is, we always think back and see, should I have to go to this or shall I manage with the same thing? So that's a cost thing. On one side, we are getting the lot of features, okay, with AIs coming in. But on the other side, you have engineers getting equipped with such features, demanding more, right? So we are stuck in the middle. So should we have to go for the licenses? Should we have to go with the engineers? Then how should I deliver? How should I catch hold of the customer? I think that's been a big challenge what we have. I just want to say that recently we got into the VLSI business as well. We have around 50 plus engineers working. So that's been open maybe 3 months back. We opened up in Whitefield. So that's one of the competencies what we have started working on. I don't want to go much in that because we are core mechanical here. So just to give an information on that. And these are the things which is for industrial what we work on. So a couple of people working in some of the domains, namely on the PCB related activity, like how we do the simulation, how we transact between the CAD and the simulation thing, and how we get the the results basically on the creepage and clearances. So that is something which has been very helpful with the help of tools. So this is an integration with the CAD, ECAD and MCAD basically. And definitely this is something where we have grown, matured well with multiple projects what we have worked with, with many customers. So I have Guru sir and Satish with whom we have interacted more, and the other projects like Herotech or Stellantis or BMW, so where we have supported with the of course the Unigraphics tool was being recently what we actually started, because predominantly it was being the CATIA. So but nowadays I think more of the projects are coming on Unigraphics, and we have a good team base now actually. We have built around 20 plus team, and at Haliyal we have around 75 people it's been built. So we started with I think it was like way back around 10-15 people, and we used to get like small tools, okay, like okay you got one tool, like, that used to go on for long, but now we're getting complete lines. I think it's like 3 to 7 lines I think we recently executed, and I think now we are concluding on a couple of projects on Herotech and Stellantis project, which is Tomo is the customer basically. So these are the BAW's offerings what we do. And coming to the simulation part, I think we have been doing the solution for the structural analysis what we do to optimize the design basically. So this is again where we wanted to ensure those structures are being optimized. Like we don't want the design could be really would have passed actually, so it would have given the fair result. But still, optimization plays a role where you can save the material to give the exact right weight of that. So in terms of that's something a big savings which will benefit the customer. So that is where we have been very instrumental in delivering that. And incidentally, we just had an you know one more customer like where we worked on the valve designs. So they have to sustain in the market. So if they have to sustain the market, the key thing is when one of his CEO came to our office, so he just talked about what is that which drives the business. I think just it was just one word. So what he talked about is the weight. So the product what they want to sell with respect to the other competitors, it's the weight of their product, like in the valves. Okay, so it's been casted one or it's it's a forged one. You cannot understand that just by the by the structure or by the cross section. You cannot understand. I don't know if AI should really help us in the future. We need to explore that. Yeah. We haven't tried that, honestly, but you did mention that, Avinash. I think how the optimization will go on. Yeah. And yeah. So this is what I just talked about on the FEA and CFT, and what are the like what we have offered in terms of static, structural, or for the grippers. And I think this is the partnership where we started with Siemens, where what we have. So I just want to quickly just run through some of the examples like what we have worked on. So I just want to hold here and quickly conclude here, like what we have on terms of where we stand with respect to the domain expertise. I think yes. So we do have a good experience. I think in past 2 to 3 years, like how we have evolved ourselves in terms of approach, in terms of managing the team, in terms of educating them, in terms of sometimes firing, yes. So, and this quality always been a paramount important, like we are going into the certification because the process is so important. Like now we are spearheading to get the certification and ensure that we are following the process to ensure that we don't have to have any gaps in terms of internally managing the projects. Like normally we dump things and we don't bother to manage those data, or in a with the process related, where we don't capture the matrix and we don't identify the right way of finding the making somebody accountable for their delivery. So these are something which has been the challenge actually. So we are ensuring those processes so that everybody are accountable when it comes to studying the inputs till the delivery. So nobody are spared actually, everybody are accountable. So that is something where offline we are just starting with. And I talked about the reduced cost. I will say this way, the cost reduction is why I was saying is like from local to global. So we have the team which is at Halia, north part of Karnataka, where we have around 70 people, right? So they have got they don't want to come to the cities actually here. So they love to be in their hometown and yet to be to work there. So locally it's really difficult. So most of them we choose Bangalore, or we have to go to Pune or some other cities. But the best thing is what we see here is like we get they stay with us for a long time, and that's something like we also in turn support them in the process. project perspective where they don't have to miss their family basically. So that is where we benefit the cost. So one way how we manage the cost here, and the flexibility in the delivery. So since our office has been like 24 bars and our own offices which are in Halia, so we don't have dearth for the timeline. So anybody, anytime we just come and we spend our time. People are locally over there. So any challenge we get, any feedback we get, I think guys are beautiful, excellent. They just, they just come back and they support us. That's been the best thing actually. That's something what is a challenge here, because some of them, yeah, I think the clock is ticking, 6 o'clock, 7, okay, I don't get a cab, I don't get these are some challenges we do face. And I think that's it overall. Thank you so much for presenting. Thank you.
Thank you, Manjunath sir, for the presentation and for your efforts and sharing the experience with us. Thank you. Now it's time for the session we have all been eagerly anticipating. I am excited to invite Mr. Aman Garg to the stage to guide us on virtual commissioning, process simulate, and plant simulation. Mr. Aman sir has worked with estimate companies such as EDEC, General Motors, and Kumau, and have 22 years of experience in simulation industry. Please join me giving a warm welcome to Mr. Aman Garg.
My friends, good evening. So I think we had two wonderful, beautiful sessions, and now I have to catch up with them. So I have to deliver good. How many present over here are from the simulation background, robotics simulation background? Okay, all right, great. So you are my soulmates. You are my soulmates because we are from the same fraternity, right? We understand each other's pains and happinesses. So Kishore had its own mission and vision, and I have my own mission and vision that is to increase my fraternity. All right, so I've been in the industry for around 22 years, and when I entered the industry, I started programming the robots. So my first robot programming was KUKA. And then what I'm going to tell here is that I have seen, or rather most of us who are present over here, have seen a lot of transformations in the digital manufacturing domain. I think you all agree, right? So we started with the shop floor online programming. Then I started using RobCAD from Technomatics, started using iGrave from Dassault Systems, right? So all these softwares were good when it came to station level robot programming or simulation, right? Then we migrated to line level of simulation, where we brought multiple stations or the number of robots were higher in a single station. Then that was the start or the beginning of the advanced level of robotic simulation. Then we had process simulate, which could handle line level of simulation, means the number of robots being handled inside the software were higher. Then came, or recently we have the virtual commissioning, right? So between virtual commissioning and robotic simulation, there have been many advancements in the digital manufacturing domain. So today we are going to focus more on the virtual manufacturing portion. Do we have that slide? So I think we started our session a bit late, but in between that time we had multiple videos being played. So there was one video from Valiant TMS where the guy who was speaking spoke about the value of speed, flexibility, quality and efficiency. Now the time to deliver new product or the roll out new product is around 2 years. Earlier it was 3 years, before that it was 4 years. The time is reducing. So all the OEMs have to roll out new product within very short duration of time. Because if they increase the time duration from 2 to 3 or 3.5 years, their product may be not attractive or non-attractive, right? So that is very important. Flexibility is the time you roll out your product. It has to be flexible. Today you have made line for one variant. Tomorrow, after 2 years, you want to add another variant to the same line. So our line has to be flexible. Our automation systems have to be flexible. Third is quality. I think no OEM wants recalls for their vehicles, right? So we have to, or the OEMs have to deliver their product in a very good quality. And second is last one is the efficiency, right? So we have to deliver the product first time right. There cannot be iterations. And we do not want our payments to be on hold because we have to be efficient. That's the reason we have to be efficient. So we are talking about manufacturing industry. So it will be unfair to say that manufacturing industry is more focused on, or we are more focused on the automotive side. It will be unfair to say that. Because manufacturing is for the automotive industry, for the heavy industry, for the electronics industry, or for the other general industry. So the process remains same for all the industries. Today, if we are catering to the automotive industry, tomorrow we can also cater to the aerospace industry or the heavy industries. The process remains same. The process is that we have to create the digital twin of the product, the digital twin of the production, and the digital twin of the performance. Avinash spoke about the digital twin of the product, that is the NX, right? So I'll be talking about the digital twin of the production, where there are two elements of the production process and the production system. The production process is basically process simulate, while the production system is plant simulation, right? So the challenge remains same for any industry, whether it is greenfield project or brownfield project. The types of challenges differ, right? So when it comes to the greenfield project, from requirements to commissioning, the customer has to ensure that the production line works as designed. While during the brownfield project, we have to keep the production line under control while introducing a new variant to that. And from the detailed design to the retrofit, we have to validate and increase the performance of lines. While for the brownfield, we have to validate changes and impacts to existing production line. So this is the complete picture what Siemens offered to the customers in terms of virtual commissioning. So virtual commissioning is offered at each and every stage of the product development. So right from the automation to component periphery, component physics also, to the production machine, which is being handled by the NX mechatronics concept designer or the NX MCD. And process simulate handles the robotic stations and lines, and the technomatics plant simulation handles the complete production line and the factory. Any idea about, I will go back to the previous slide. Anyone can raise hands and tell the difference between the top three, the production line, robotic station and production machine. Anyone who can raise hands and tell the difference between these three. Okay, I think everybody knows, but nobody takes the day to come up and answer. So today we are going to focus on the technomatics process simulate virtual commissioning, right? And when we do or develop our technomatics workstation in process simulate, we are dealing with the automated lines. So the automated lines can be run only with the PLCs when they are integrated with it. So if I say I've done the simulation without PLC into it, so that's the half work done. So it has to be integrated and verified and validated with PLC into the picture, right? So the automation, we have the PLC Sim Advanced and WinCC. So before I go ahead and talk about the integration of process simulate with multiple PLCs, I mean, it's not that process simulate integrates with only Siemens PLCs. So integration is with all types of PLCs available in the market. So that's a holistic view of how the process simulate virtual commissioning takes place. So we have two types of, or the two ways how do we do the virtual commissioning. One is the hardware in the loop and second is the software in the loop. So hardware in the loop means I have process simulate where I have created the virtual factory that's on my laptop or desktop and I connect it with the physical PLC. The PLC is placed on my table and I connect directly to my process simulate and that PLC is being controlled by its control software like TIA Portal or RS Logics, whatever it is, right? So that's how what we call it as the hardware in the loop. And the software in the loop is that I don't need a physical PLC. So I connect directly my TIA Portal with process simulate environment or another like RS Logics is ready. So all can be connected. So between the hardware in the loop and the software in the loop. So we have been doing the simulations for a very long time. The traditional way is that there have always been involvement of the design team, the robotics team, and the controls team. So there has always been fight between these three different departments when it comes to execution of the projects, right? But all these work in a sequential manner, which is not the right way actually. Because when design completes its work, it hands over to robotics, then it hands over to controls. While it has to go hand in hand. So it has to be concurrently working together, right? So that is what the new way which virtual commissioning brings into the picture. So if we do that, we are going to reduce the time to commission or the complete project execution. By doing that, we are going to reduce at least 30% of our total project time. And I'm not saying that we have customers who have done that, who have achieved that, and we have testimonials of them documented as well. This is standard. I think all those who have been working on process simulate for a very long time, they know that they have to prepare the work cell before working on the virtual commissioning. So the steps are, you have to have the initial layout, you populate the work cell, bring the components or the equipments at the right position, provide kinematics, do the reachability test and all those things, define the equipments, then you create the path. Right? When the path is created, I mean, when I say the path is created, that is a robotic path. So the robotic path is created, then you have to find out whether that robotic path is collision free or not. So the target is, I have to create a collision free path. So once the collision free path is created, then I can generate an ABI file which can be sent to the shop floor guys to refer to. This is one way, very orthodox traditional way of doing the simulation. By doing this, what I am doing, I am validating my equipment. Equipment here is the robot, its reach and capacity, right? And the mechanical design, whether all the fixtures being designed are okay or not, right? So all these things are being validated. And this is being done as the basic robot programming, basic robotic simulation. So that's the beginning of, or the base work or the foundation work which is required to do virtual commissioning. So, I mean, if anyone has any doubt or not connected to me, please tell me, stop me, and if somebody wants me to repeat it, please let me know. All right. So in this case, what you see here, it's a battery pack assembly, robotic cell, where we have the robot and a gripper mounted in front of it. and we are validating its path, and in order to have the collision-free path, we created some wire points in between, and later on we are defining the attributes. So how the robot is going to move between different points in a linear way or joint way, and what is the type of motion and what is the speed. So all these things are being defined over here. So the next step is, after we have done that robotic path validation, now we have to have it validated along with the PLC. So when I say validated along with the PLC, that means a simulation engineer is not doing the job of a controls engineer. Controls engineer, please feel safe, your job is intact, because you are doing your job only. So I'm just going to bring you both together, right? So you both are working together. Controls engineer will write his own ladder logic based on the inputs from the design, and the robotics engineer will create the work cell based on the inputs from the design. So both will work together, and now both are integrated. On the left hand side, you see it's a window of TIA portal, and on the right hand side, it's a process simulate environment. So whatever signals are being activated inside TIA portal, the same command is given to the process simulate. Right? If I say, if the controls guy say, open this clamp, the same clamp is then opened inside the process simulate environment. And you also give the feedback to PLC that this clamp is now open. Now, when I do virtual commissioning, then these are the 4 important tasks which are listed on the left hand side. Validate and debug control logic, test communication interlocks, virtually test HMI screens, and verify safety programs. So during this process, or during this validation, what I need to have? So I need to have the process simulate, and I need to have my controls software. In this case, let's talk about TIA portal, right? So these 2 things are very important. So when we are connecting these 2 in the software in the loop mode, then we need to have the PLC sim advanced as well. Not from you. So in this case, the connection between process simulate and TIA portal is already established. And on the right hand top corner, you see it's a HMI. It's the same HMI which will go onto the shop floor and will be uploaded onto the actual PLC. So here we are doing very initial check whether if I press one button for the conveyor operation, whether the conveyor is running or something else is running, right? So by doing that, we are just validating the first step. Now in this case, we see that the multiple so this is the HMI, and these are multiple stages where the conveyor is going to move. So whenever the conveyor moves to that location, that specific sensor gets highlighted and it is being displayed over here. Right? Now, it is not always true that whatever I do will be 100% correct, or whatever the controls guy does will be 100% correct. So, the debugging is very important. So, in this case example is taken, if I run the conveyor and if I try to stop it, it isn't stopping, it isn't halting. So, we need to make some corrections, we need to do the debugging. So, for doing that, we'll go to the ladder logic inside the TIA portal. So the controls engineer will verify where the problem is coming from. So after he identifies the problem, he makes the necessary changes to the ladder logic, saves it, and download again back to the PLC. Then it is again connected to the process simulator environment. And then we run the simulation again, and then we validate the same things, that if whether the conveyor is stopping or not. So it's as easy as that, that you don't have to wait for actual commissioning to happen to make those corrections. So by doing that, we are actually starting our commissioning process quite early, right? And then definitely when we go to the shop floor, we have very few errors, and the time to commission will be quite faster. Second is testing the commissioning interlocks. We are always talking about the time-based simulation and the event-based simulation. So when we are doing virtual commissioning, we have to complete our basic simulation in a way that it is an event-based simulation. So that means if a step has to be done, then before that, what are those events which have to be completed? Like if a gripper has to pick the part up from the fixture, then a part has to be present on the fixture, right? So if the part is present on the fixture, only then gripper will go and pick the part up. So this is the event. So in this case, what you see here, that the robot 2 will pick, this is the robot 2, will pick the part, but will not be dropping anywhere because it doesn't have any tray in front of him, right? So when a tray comes in front of this robot, it immediately senses that a tray has arrived and it has to drop the part. Now it has immediately dropped the part on the tray. So this is how you check the interlocks, and on this side, this is the simulation panel where you have created all those signals which are required to be connected to the actual PLC. So when you create these signals inside process simulate, how do you know that it is connected to the actual PLC? You have to map those signals to the actual PLC. If signal number 1.1 says that the conveyor has to run, then it has to be mapped with the same PLC signal. So that collaboration is part of that commissioning process. So in this example, again we are talking about some debugging cases. So what you see here, that this robot has to pick this gripper up. It is a docking station. So what we see here, that whenever we enter the program number here for docking, it goes to pick up the gripper, but it doesn't pick it up, right? We do counter these kind of situations on the shop floor, and we solve them, but it takes time, right? When a controls guy is working on the shop floor to solve this problem, then everybody else around him is also waiting for him, right? So in this case, if we solve this problem here itself, then most of the problems which go to the shop floor are sorted at the first stage itself. Right? It's the same step again where the controls guy verifies where the problem is. He identifies those problems in the controls logic, ladder logic, modifies it, saves back to PLC, and run the simulation again. Now just observe, just within few minutes, or of course this is an AVI, but if it has to be done, by the actual engineer, he will not take more than half an hour to do this activity. So testing the interfaces is quite easy. Debugging the logic is also quite simple. The beautiful part is that the HMIs which you see here, or the HMI programming which you see here, it is the same which directly goes to the shop floor. So it can also serve as a training guide to the engineer working on the shop floor. So you can bring him to the design office, train him, and he will have his own feedback, and he can go back. When he goes back to the shop floor, he is already trained engineer. Wherever this trace, the same signal is getting, the same sensor is getting highlighted. Now, the next, or I would say the most important part of doing virtual commissioning is to validate the safety. I think everybody will agree that safety is the most important thing, because whenever some breach is happening, it is not only the breakage of the equipment, but human factor is also there, right? So we cannot test all these things practically on the shop floor. So if we have certain system where we can make all those checks here in the virtual environment, then it is a blessing. So what we are trying to see here, when I apply the emergency stop, whether all the robots are stopping or not. This is one check. If it is stopping good, then we just reset it and rerun the simulation. In second is, in this case, you see that when the door is open, I saw that the robots have not stopped. They should stop. So I go back again to the ladder logic and verify what is missing and make those corrections, and again download that program back to the PLC. So after these changes, I'll again run the simulation, open the door and see whether the robots are brought to stop or not. So I can run the simulation using the manual mode and auto mode, using the same HMI. Now this is what we want to achieve, or want to see, that the robots should stop when the doors are open. And when the doors are closed, it should again reset and start from there where it was stopped. So definitely it ensures safety virtually before the hardware arrives and minimizes the risk during the production ramp up. So definitely it reduces the risk of physical damage. Virtual testing increases physical safety. Commissioning starts before hardware delivery, right? Debug and fix occurs earlier in timeline, shorten physical commissioning time, and production start up begins earlier. So I think in the last few years, our customers in India have started to accept the benefits of virtual commissioning. And many organizations have wholeheartedly accepted the virtual commissioning and brought it to their systems. So that ends my presentation actually. And if anyone has any questions, we can discuss it now only, or I think we will be in a better state after few, after half an hour or so, so we can discuss around that time also. Yes, please.
Just two questions. One thing about AB, like Alan Bradley. So earlier I think it was with only hardware, right? Now do we have any?
Yes, we do have. Earlier supporting Mitsubishi also. Mitsubishi is also being supported in software in the loop. And because Siemens virtual commissioning has good presence, most of the PLC makers have developed their software which will support the software in the loop for processing.
The second one regarding this brownfield.
Yeah.
Like, okay, greenfield, everything is like fresh setup, so
Yeah.
it'll be easy, but when it's brownfield, so how to tackle, like, there can be daily changes in the PLC program, and on the other side, we'll be doing the virtual commissioning. So how to tackle, like, what do we
See,
do?
the first and the foremost requirement for brownfield is to have the virtual setup in process simulator. If you do not have that work cell of brownfield in process simulator, it will be really difficult to do that. So you need to have. So if you do not have, then there is a point cloud. But that point cloud can bring all the data, but again that requires a lot of exercise from your end, who is the line builder. So he has to work on that part of bringing the data into process simulator, recreating some of the stuff, uploading the programs from the shop floor to the process simulator. So that exercise has to be done in order to fully support the virtual commissioning or brownfield.
So basically, any changes happens in the shop floor, it has to
Yes.
have the
Even after you complete your greenfield project, there will be always some difference from what you have done in process simulator and what actually runs on shop floor. So you again go back to process simulate and upload the actual running programs in the process simulator, so that you always in sync in what is happening on the shop floor. Yes.
My name is Vinay.
I know.
I am from De facto.
I know.
Yeah. Sir, I have two questions. We already tried virtual commissioning. Based on that, first question, cycle time check. Generally, we are doing before VC in line simulation mode, and we are achieving it on site. But now, customer demand, he wanted through VC also. So now we tried one of our past project. So in that, say around 4 welding robots working and 1 handling robot. So what happened? We tagged everything. So logic debug is also happened. Whenever we'll start with data logic, like three times data input. First time whenever data is given, so it went smooth. Second time what happens? First robot will get start immediately, so it will move. But second robot again it is not get start. Then parallel PLC person, he is rushed to high, that robot is not get that start.
Everything is in virtual mode.
Virtual mode, yes. So he is checking with multiple window. We had some lab setup also. So he got what is the issue. Suddenly he will make that correction. Till that one robot will complete that welding time. So then again third logic. So one or the other issues is coming. So for that we cannot show 3 to 4 cycles, cycle time to the end customer. One cycle we have done. So customer is agreed. But 3 cycles we are unable to do, and we tried multiple iteration also. Till that our execution time came.
I think we need to discuss that offline, because that should not be an issue. There could be some other things we need to discuss, I think, because you're saying that we can run only one cycle, but it isn't true actually. So we can run multiple cycles, and I think we have multiple use cases where we have seen that customers performing. I mean, we can discuss that later on.
Yeah, sure. And second point is what happened because of some robot is not getting start. So our simulation panel is running 500, 600 seconds, 11 seconds. After 2000 seconds, so PS will get crashed. Okay, but till that my logic is welded for out of 10 station, 5 station is logic is welded.
Which version of PSC you are using currently?
For that we are using 16.1.
Okay.
So maybe in upgraded version we
Yeah,
do that.
because there has been many upgrades. Presently we have 2406. Even the graphics engine has improved tremendously in the newer version. You will see the performance update from 30% to 70% when you see 2406.
Yes, sir. So whenever PS will get crashed, but PS state will be that middle of that logic only. But again we will start PS. So we are at start of the logic. Then again
The latency rate is good.
yeah. So like that. So that is the one issue we face. And one more is mechanical actual times. Pneumatics, whatever is there, site it may be 3 seconds or 4 seconds based on
Because
the
see, when you talk about pneumatics in process simulate, Pneumatics is the value driven by our experience. Now you say that the clamp open takes, let's say, 1.5 seconds. You put 1.5 seconds. The same will be calculated in the cycle time. But if it is 3 seconds on the shop floor, then some setting has to be done on the shop floor to reduce the time of the clamp.
That's it. Thank you.
Virtual commissioning. We now move on the another case study session. I am happy to welcome Mr. Ashok sir from Innovative Engineering Private Limited to share a detailed case study on their experience and application on Process Simulate. Please join me welcome Mr. Ashok sir.
Good evening all. So, thank you very much for this opportunity. Myself, Ashok Amangi. I'm working as a project manager, robotic simulation in Innovative Engineering. So today I'm here to present not the case studies actually. So to give you, to take you all through a quick overview about the traditional robotic simulation and role of process simulate into the robotic simulation. So before we jump into the robotic simulation, so I'd like to take you all through a quick look about our company profile. So we, Innovative Engineering Private Limited, we started our operation in the year 2016, and since last 8 years we are serving many customers globally, and our main focus is in engineering design services. We are operating through globally in 2 different locations. One is German Honu and from India, Banglor, Pune. So in Pune we have one unit in Pune, and we are going to start a new unit also in the same Pune. And to tell you about our expertization, we are experts in process planning, mechanical design, then robotic simulation, OLP, and a little bit about a virtual commissioning also. And to tell you about our strength, we are a family of around 70 plus members. I already told that our global presence is at 2 different locations. And so far we served around 25 plus customers. And the domains we served are different. And the design hours we executed will be around 200K plus, and simulation hours are around 80K plus. And our expertization in manufacturing is on mag welding, then the BIW welding, assembly fixtures, and some special fixtures also. Our capability in automotive BIW is like we are working on the layouts preparations. So it will be a 2D or 3D. We are working on the layouts, and then the design. Design, we are almost using all the design softwares, including NX, KTI, everything. And regarding the robotic simulation, so in simulation also we are using most of the projects are in Process Simulate, and some other softwares also we are using. And then we do have our expertization in the OLP. We worked on the different robots, creation of OLP for the different robots like a Fanu, KBB, and Kuka. And for some few of the projects, we have done the complete line delivery also, including assembling and installation and commissioning. And our design capacities, as I already mentioned, we are around 70 plus members. So in mechanical design, we are around 55 plus members, and in simulation, we are around 14 members. And in QC quality, we have around 4 members. Very recently, we started QC in the robotic simulation also. The basic intention is to serve the quality work to our customers. So that's all about our design capacities. So now I just quickly jump through like traditional robotic simulation. So and process simulate, how the process simulate is going to help us through carry out all this robotic simulation works. So the points which I am going to cover, like outline of robotic simulation in BIW, then standard components of simulation, what is the data format what we are following in the process simulation, and inputs and outputs of simulation, and what are the different softwares we are using for the simulation, and then the process simulate overview and its role in simulation, and finally the final outputs to the customer. Yeah, definition of simulation, you all know that simulation is nothing but an imitation of the real world manufacturing, representing the real actual manufacturing process. So whichever the operation involves the human entry, so all those operations we are going to validate and check. So those simulation we call as the ergonomic simulation, and the last one is the robotic simulation, where actually we are working. So where we are going to study the behavior of a robot in a different parameters and surrounding environment, and we wanted to know that how the robot is going to behave by varying the different parameters. So that's a robotic simulation. So benefits of robotic simulation. So before I jump to the benefits, I'd like to ask you that what is the most costliest thing in the world? If anybody can let me know. Exactly. So time, in the current industry, time is the most costliest thing. So one of the great benefit of robotic simulation is time. We are going to save the time. At the same time, we are going to save the cost also in different ways. Sometime we, being a simulation engineer, to save a 0.5 seconds of a cycle time, we will spend around 7 days. I don't know how it is going to be a beneficial, but yeah, it is actually a beneficial one. So benefits of robotic simulation, like it is going to reduce the cost. If there is any changes or any mismatches in the product design itself, which we are going to identify them before punching the product. So it is going to help us, and then comes we are going to validate the complete process and optimizing that. Then we are going to check the reach study of the robots and optimize the placement of all the robots, equipments, everything in the simulation cells. And then whatever the fixture design has been done, that also we are going to validate and optimize them. Check for all the clearances and near misses or the collisions, whatever, if any. Then we are going to identify and solve them. So it is also going to help us to save the time and the cost. And then we are also validating the basic layout, what we have at the beginning. So whether the layout is going to work or the space what we are having, it has been enough or is there any change is required. So that also we are going to validate. And then the cycle time analysis. So as I mentioned, time is one of the most costliest thing. So we are also validating the time required for each operation and a complete line. So that is also one more advantage. Then ergonomically the process is safe, or is there any hazards involved in the operations, that we are going to check. And any costly mistakes, like if I buy some wrong selection of the robots or guns, so that also we are going to validate by checking the payload and reachability, accessibility of the guns into the fixtures, and the force required for each spot. That everything we are going to validate. So that is also helping us to save the time and like a cost. Then comes, as I already mentioned, it is going to, simulation is helping us to save the time. Then the OLP programs, what we generate in the simulation can be directly installed into the real robots. That also going to help us to save the time. And some of the 2D and 3D sections of the panels we can generate it through the process simulate, and they are going to help us to create a optimized design of the well guns, so that we can save some time on that also. And then SOP, sequencing of operations, where we are checking a permutation and combination of different operations to check the time required for each and every different scenarios, so that whichever is taking a less time, that scenario we are going to adapt into the real world. So these are some of the benefits of robotic simulation. And we all know that there are different robotic applications in BIW: material handling, ped welding, ped sealing, spot welding, laser welding, stud welding, riveting. There are many operations where we are using the robots to carry out the operations. Some of the standard components in simulation, like robots, of course, we are doing the robotic simulation, it's the robots. And then the risers, weld guns, light curtains, so this all comes under the safety of the operator and equipments. Then the roller doors, cable tray, through which we are passing all the cables and pipings. And then comes the 7th axis robot. Yeah, sometime only with 6 axis will not be able to perform, make an effective utilization of the robot. So we add a linear axis also to use the same robot to carry out a different operations at a different distances. That is the 7th axis. And then comes the tip tracers. So we wanted to retain the original shape of the tip of the guns. So we want to trace them frequently. So tip tracers. And then comes robot and well controllers. End effectors. The tool which are getting mounted to the end of the robot, we call them as a UAT, end of form toolings. So it might be a handling gripper, or it might be a gun, paint gun, arc welding gun, or a spot welding gun, or a rivet gun. So anything it might be. That we call as a UATs. Then the welding guns. So there are different types of welding guns. So IT gun, C gun, X gun, laser weld guns, paint guns. So we do have a glue or sealant application, so we are using the glue guns. Then the pedestal welding guns, wherever we have to carry out some stationary welding operations, then we do have pedestal weld guns, stud guns, MIG welding gun, rivet guns. So these are all some standard components what we are using in the robotic simulations. And now the inputs and outputs of simulation. Inputs, what we need to start our work is like a basic process, which has been defined by an OEM. So that basic process we need, and the basic layout, and the car parts on which we need to carry out our operations, robotic simulation operations, and check the welding. Then the weld spots, fixtures, and other toolings comes into the picture net. Then the outputs what we are going to give from the simulation are like offline programming, the complete program generated in the simulation software can be directly installed into the real robots. That we are going to give as an output. Then comes the realistic robot cycle time. So we are going to validate the cycle time for each and every operation, and then we are going to give the complete output of the cycle time. Then the robot mounting sheets. Then the movie files, simulation movie files, layout files, the finalized layout files. So these are some of the outputs of the simulation. And to coming to simulation software, there are many softwares. Some of them, the most commonly used are RobCAD and Process Simulate. RobCAD is already been obsoleted now. So now most of the projects what we carry out by using the Process Simulate. Then there are some of the simulation softwares which are based on the specific robot specific also, like a Fanuc RoboGuide. So that is the simulation software for Fanuc robots, and it handles only the Fanuc robots. And the ABB, we have Robot Studio, which handles only the ABB robots. KUKA Sim, which handles only the KUKA robots. When it comes to Process Simulate, which is capable of handling all the robots, like it doesn't make any difference with ABB, Fanuc, KUKA. So Process Simulate can handle all the robots, and we can carry out simulation operations. So on all the different robots. Yeah, some of the common types of robots are like ABB, KUKA, Fanuc, Automan, Nachi, Kawasaki, and they have their own controllers. Like for ABB it is IRC5, KUKA KRC4, Fanuc RJ3. Similarly for Automan it is NX100. Yeah, some of them you might be knowing that it is a starting screen of Process Simulate on which we are carrying out our robotic simulation operations. Yeah, in that also we have some of the modules which we are using in the simulation, like a modeling module, where we are carrying out some basic modeling operations, some of the blocks, building, or even the cylinder creation, all those things we can create by using the modeling module. And we are also using this for the application of the kinematics for guns, grippers, and to define the self origin or the working origin of the cell. So for this we are using the modeling module. And then comes the robot. So robot module we are using to check the robot reachability and smart placement of the robot into the layout, and also to configure the robots with the different joint configurations. Then comes the operation. So in the operation, we are going to create a path. So where we are generating all the wire locations and optimizing them, and sometimes we create a sort value to understand the interlocks between the robots. And then comes the process module, where we are importing and projecting the MFGs like well spots or the rivet points. And we are also generating the gun search, a smart gun search for the required MFGs, and then cloud generation also we'll do in this. So, and even multi-sections creation can be done in the process module. And then comes the control module. So control module, most probably it is going to be utilized in the virtual commissioning where we are generating the logic blocks, and then sensor creation, signal mapping, that everything can be done through this control module. And then comes the human module, as I already explained that whichever the operation involves the humans, so that also we are going to validate here by using the human modules, where we are going to check the reachability of the operator and the weight lifting capacity and even the vision study, like whether each operation, so whether the operator is going to utilize, visualize them clearly or is there any problem, that also we are going to validate here in the human module. And the file formats in the process simulate, so it is a .cogt file. When it is an individual component file, we call it as a cogt file. When it is a combination of all the cogt file, or you can say it is an assembly file, we call it as a PSZ file, process simulate zip file. Yeah, finally, the outputs what we are going to give to our customer is like a pack and go of the cell. So once after finishing all the robotic simulation study, we are going to send this complete pack and go of the cell. And then the layout, finalized layout after making all the placement of equipments, after optimizing and finalizing the equipments, we are generating the layout, and that also we are going to send to the customer. And then the spot weld matrix. So where we are mentioning which spot has been getting welded in which station, that all this information we are going to send it through this weld matrix. And then the gripper mounting, gun mounting sheets, SOP, that is the sequence of operations where we are generating a movie files, and some of the documentations also, like a robot data sheets, and then collision list. So finally the cycle time sheets. So cycle time sheets also, as we are validating the complete cycle time, how much time it is going to take for each operation. So finally we will modify and optimize all the operations so that we have to bring the complete operations within the time. So that also we are going to carry out, and finally we will send the cycle time sheets, validated cycles and sheets will be submitted to the customer. Yeah. And now coming to, so how Rainbow has helped us to carry out all our robotic operations. In one of our previous projects, customer asked us to work on the robot safety module and cable simulation module. And even it was a Fanuc robot, so we wanted to work on the Fanuc OLP also. And setting up an EM server, connected version, we wanted to work. So, which was completely new for us. So, but as soon as we got to know that we need some of the support, so we called the Rainbow, and they extended their hands and they supported us in all the operations. So, yeah, we are very much thankful to Kishore and team for all this support. Yeah, thank you once again. Yeah, this is our premises where we are operating from this location in Pina. Yeah, so that's all about a quick overview about our robotic simulation. Thank you all for this opportunity.
On the next session of the event, today we are not only here to explore the latest advancement in our field, but also we to recognize and felicitate our valuable customers who have been integral part of our journey. It's our honor to acknowledge and appreciate the trust and support for our customers have shown us over the years. Their success stories are a testament to our power of collaboration and innovation. I would like to invite Kishore sir for come on the stage and few words about the customers.
Joining and what you can say, coming here. So I just want to talk something. हिंदी समझ में आता है सबको? Everybody knows? Yes. So एक वक्त था जब I recently started exploring Bangalore and I was looking for the business. Then many people helps. So the first person whom I met and my colleague Mr. Mahesh met was Mr. Murli sir. So today he was not here, but it was his passion and the way of working and the what you can say confidence that he has given to us that you explore the market, we are there for you. And So I would, what you can say, my gratitude to sir, or the words are very less for him, because we are here and we are growing. So thank you, sir. I would again suggest. So on this, I would request Mr. Harsha and Gagan to come on the stage, so that we can felicitate them.
And plant simulation, Siemens NX software for their solutions. We would like to invite the Director of Innovative Engineering, Mr. Guru Sir, Mr. Vijay Sir, and Santosh Sir to come on the stage for the gold medal presentation. Please also come on the stage, Ashok Sir, for the your felicitation. I would like to invite Mr. Aman Sir to come on the stage to felicitate our valuable customer. Some words about your experience about
Thank you very much, Rainbow Technologies, for this event. So it's been very grateful engagement with Rainbow Technologies, especially the technical support from Praful. So he is always available for a quick turnaround support. And it's been very good experience with engagement with Kishore and his team. So thank you very much, Kishore and his team. Yeah. Thank you.
Thank you, sir, for your presence here. Now it's time to welcome our next valuable customer, Praxentech Solution Team, Director of Mr. Narayan Tosur sir, then Manjunath sir, and Harish sir. Please come on the stage. I would like to invite also for the Avinash sir to
Mr. Kishore and team. Thank you so much for inviting us, and it was a wonderful journey working with you. The Rainbow team is very aggressive as well as very polite and very supportive, very cooperative. Definitely they are in the right path, right journey. I think they are taking all of us together. With their help, I think we are doing wonderful projects and on time, and regularly they are in touch and regularly support us whenever there is a critical support required. Thank you so much once again, and wish you all the best, Rainbow team.
Thank you, sir. We will now like to invite virtual Mantech team, Mr. Kumar sir. Please come on the stage for your well-deserved felicitation. For this felicitation, I would like to invite Nitin sir. Please come on the stage too.
Virtual Mantech. So Mr. Sudhakar is the another director. So you cannot believe, sir is in Germany, and we are talking almost 1 month for the deal, first deal that we have happened, almost 50 lakh without seeing each other. So this is the trust that they have put on us, and also we are able to prove it. So thank you, sir, once again, and thank you for your trust on us. Thank you, sir.
I would like to invite Mega Rubber team. Please come on the stage for well-deserved felicitation. Venkatesh sir and his colleague. For this felicitation, I would like to invite Amol sir to felicitate our customer. Venkatesh. My honor to invite Mr. Nitin sir from Siemens to stage to deliver the vote of thanks.
Thank you, Praful. Thank you, Kishore. And first of all, and which is very important, it's an honor to have you guys here. Thank you very much for giving your valuable time and to understand on our products, capabilities, and our vision with the customer. Having said that, we have been through a few beautiful moments, and this is how we intend to grow along with our customers. Growing alone is not any objective; it won't be possible. We would like to grow along with our customer. In fact, when this session was happening, I got a call from one of my customers from Pune, and he was very happy. He said, "Nitin, आज हमने हमारा 50वां license खरीद लिया." And I remember 6 years back when we started a journey, we started with the one license only. I'm talking about CAD only, not a PS, CAD. So from that one licenses to 50 licenses. So we have multiple examples like this, and we would also like to thank customers like Innovative, Praxian, Involve, who are helping our partners, who are trusting our partners and giving them chance to associate with them. So thanks once again, and I would also like to thank Rainbow team for this meticulous planning and making this event successful. I would like to thank my colleague Amanji and Avinajji for sharing our vision and how we would like to grow with our customer, the whole story. I would like to also thank my partner team, Saurabh and Vilesh. Thank you very much for being here. And before we close, I know it's 9:15, we are getting late. I had created a script, but of course, मैं नहीं करूँगा वो, don't worry. So in case of any queries or anything, we are available during dinner and networking sessions. Please reach out to us. In fact, you might have anyway Kishore and their team's number. You can reach out to us for like virtual commissioning queries or Annex X. So we would love to have you again and discuss more on how we can like cater to your requirements. And dinner and cocktails will be served over here, and we can interact during that time. Thank you very much, and really honored to have you again. Thank you guys.
We would like to capture this moment with a group picture. I would like to invite everyone to come on the stage for a photo. Please, everyone come on the stage.